Let us look at this problem. From a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, a conical cavity of the same height and same diameter is hollowed out. That means from a cylindrical block or from a solid cylinder, a conical cavity is taken out. Find the total surface area of the remaining solid to the nearest centimeter square. Let us look at the figure. If we talk about the figure must look like this. Okay, so this is what? This is a cylindrical body, a solid cylinder, which is having the diameter 1.4 centimeter and height 2.4 centimeter. So we have the height as 2.4 centimeter, diameter as 1.4 centimeter, and if the diameter is 1.4 centimeter, radius is definitely going to be 0.7 centimeter. So just by looking at it, we can see that this conical cavity is taken out of this cylinder. So what is going to be the surface area of the remaining solid? It is going to be the sum of the curved surface area of the cylinder added with the curved surface area of this cone. Also, we need to add the base area of this cylinder as its bottom portion is solid, it's not hollow. So let us now solve this problem by writing what is given to us. What is given? The very first thing is height of the cylinder. Height of cylinder, we will take it as h, is given as 2.4 centimeter. Diameter of the cylinder, is given as 1.4 centimeter. So this implies that radius for the same, that is r, will be 0.7 centimeter. That is the half of the diameter of the cylinder. Also, this radius will be the radius of cone. So if it is also the radius of cone, we need to find one important thing, that is the slant height. So what is going to be the slant height of the cone? As we know that slant height L is the square root of the addition of the height, square of the height of the cone with square of the radius of the cone. So in the process of finding it, when we substitute the values, the h over here is 2.4 centimeter. So it is going to be 2.4 square, and the radius here is 0.7. So it is going to be 0.7 square. When we further solve it, we are going to get the L as 2.4 square is 5.76 and 0.7 square will be 0.49. When we add them, we are going to get 6.25 centimeter square. And when we take it out of the root, we are going to get 2.5 centimeter as the slant height. So we just found out the slant height of this cone. Now as we have the slant height and the radius and the height of the structure, let us find out the total surface area of this. Okay, so here it is. We have now enough space to do the remaining portion. So what is going to be the total surface area? The total surface area of solid, as I told you earlier when we were discussing the diagram, will be curved surface area of cylinder added with the curved surface area of cone, and also we need to add the base area of the cylinder. as the cylinder is solid. Okay, let us now substitute the values. The total surface area of solid is going to be the curved surface area of cylinder, that is 2 pi r h, added with curved surface area of cone, that is pi r l, and added with the base area of cylinder, that is pi r square. If I try to take out the common terms, I'll get pi and r as common in all the terms. So I am left with 2 times h added with l added with r. Right? So let us substitute the values now, as we have reduced the formula to its lowest terms. So what is pi? Pi is going to be 22 by 7. Radius given to us is 0.7. And when we do this bracket, it will be 2 multiplied with height, and the height, as we have seen over here, is 2.4. So it is 2 times 2.4 added with the slant height, which we just got as, so it is 2.5, and the radius, as we know, is 0.7. This everything will be in centimeter square. So let us solve it. If I cancel this 7 with 0.7, I'll be left with 0.1. So 22 multiplied with 0.1 will give us 2.2 multiplied with, if I multiply 2 with 2.4, I am going to get 4.8 plus 2.5 added with 0.7 will be 3.5. Now the total surface area will be 2.2 multiplied with the sum of 4.8 and 3.5. What is going to be the sum? The sum is going to be 8.3, if I am not wrong. Right? 4.8 added with 3.5 will be 7.8 and 0.5 will be 8.3. And if we further multiply this, what is going to be the product? Let us find it out. Let us take 83 and 22. 6 times 2 times 8 will be 16. So it is again going to be like this: 6, 12, 8, 1. So it is giving us 18.26 centimeter square, and that also, as it says, we need to write it to the nearest centimeter square. We are getting the total surface area of the solid as 18 centimeters square. This is our required answer. If we again look at this problem, we were being given with the height of the cylinder, we were being given with the diameter of the cylinder, we found out its radius, we also found out the slant height of the cone, and then we substituted the values in the given formula, which happens to be the curved surface area of cylinder added with curved surface area of cone added with the base area of the cylinder. When we substituted the values and rounded off to the nearest centimeter square, we are getting the total surface area of the solid as 18 centimeters square. So I hope this question is clear.